So let's experiment it in the PLC program. So you come to these basic instructions. Under this bit logic instruction, okay, you see SR and RS. So for the SR, drag and drop it in the SR flip-flop, okay, and then for the RS, drag that one and drop it uh, in this RS flip-flop. Are we together? So like I said, I'll be using I10.0 to set. Let me give this one the memory address M0.0. Like I said, you can put an output address there too. And I10.1, let me put it here. Okay, I would love to put a coil here. So let me name this Q6.0. Okay, don't forget I'm using I10.0 as my set, and I'm using I10.1 as my what? Reset. I10.1 will serve as my reset, and I10.0 will serve as my set. Okay, so let me give this memory address M0.1, and then let me put an output here. Let this be Q6.1. Are we together? So let's compile and then download it to the PLC. Okay, start search. Okay, load. Yes. Okay. Load. So now that I've downloaded, let me monitor the program. Okay. So let's test run our program. So the two buttons are not pressed at the moment. So the two buttons are not pressed at the moment. So for that reason, the RLO is 0. So they are taking the last states of they are taking the state of reset at the moment. So I am going to set by activating the 10.0. Okay. So you observe that the output remain on when I set it. So, and as it is, it will remain in that position forever, except I reset it. So let me attempt to reset. You can see that after resetting it, the two went back to the state of 0. So, and it will still remain in that position until until I activate the set again. So let's now see how the two will react by the time I activate the two of them at the same time. So let's say can you see the two, both the set and reset is the start and stop button that serve as set and reset are activated at this moment. And what did you notice? For the SR flip-flop, your output is not coming on. So the reset take priority. The reset is dominating that circuitry. While for your RS flip-flop, the set is dominating, and that's why you can see that your output is what is coming on. Now, my question is this: in what application do you think each and each of them can function? In which application? You say start and stop. SR. Okay. What of RS?
Yeah. What of RS? I think you can still use.
Okay, let me put it this way. What does each of them prioritize? The
SR resets, RS sets.
RS prioritize set. What's the implication of what they prioritize? For SR now, it means that it prioritize uh, to stop, to make sure that the stopping is more important to SR than starting. Okay, it is more important for a system to be off than for it to be on for SR. But for RS, it is more important for a system to be on than for it to be off. Now, based on that analogy, what can you say about them?
So I think it can find application in safety conditions.
Thank you.
Let's say maybe the machine is currently working and you need to immediately stop it, regardless of whether it is being started or not.
Okay.
So you can use an SR flip-flop in that case, where you immediately press the one that has a reset to stop.
Okay.
Then let's say in another condition where somebody is maybe under a vehicle or maybe you are in a compartment and you need to be pulled out by a machine regardless. So that RS will work because the sets will kind of trigger something that will pull you out of that confined space or something.
Okay. It all depends on how we look at it. So, but if you remember the application, the program we wrote, I think 2 or 3 days ago, for where we have some conditions stated that the stop and safety condition is prioritized. Can you remember that? So where it is more important for you to be for the stop to be active than for the start to be active. Okay, so when you want to program a safety condition, okay, you use an SR flip-flop. Why? Because for SR flip-flop, reset, that is making the system go to stop mode, is the priority. Reset dominates set in the SR flip-flop. So when safety is of importance, okay, use the SR flip-flop. Okay, but when what is important to you the most is for your system to be on, you can now use the the RS, which is reset set flip-flop. So that is it. Now, the task I want to give us at this moment is that now we see how set and reset work. So I want us to write a program using just our normally open and normally closed instruction. Write a program that works as a set reset flip-flop and then write a program that work as reset set flip flop. So write those two programs. Let's start with the set reset flip flop. So you are going to be using your normally open and normally close instruction. So write the program and it must work like your SR flip flop.